All right, awesome. All right, so thank you guys, everyone who showed up today for this morning's webinar. I do have Mike Eno and Mike Maggio here from Bearings Limited, and they're going to have a presentation on Bearings 101. So, Mike and Mike, whenever you're ready, go ahead.
We're ready.
All
Thank you.
right.
Good morning, everybody.
Hey, good morning, everybody. Thanks, Nicole. I appreciate the opportunity to do this Bearings 101 webinar. My name is Mike Maggio. I'm from Bearings Limited, and my partner is Mike Eno from Eno Industrial.
Morning.
Bearings Limited has been around for 47 years. I'm sorry, since 1947, which is about 75 years. We're the manufacturer of Triton brand bearings, chain, sprockets, and mounted units. We are also a very proud partner of Rumsey, and we are supporting them in their bearing and PT endeavors. So I really am pleased to be able to present to you guys today. Bearings 101, what we're going to be going over is the basics. Basics on radial ball bearings, mounted units, chain, and sprockets. It'll probably go about a half hour. And actually what I'd like for you guys to do is if there's anybody has a question while we're presenting, please feel free to just speak right up and I'll do my best to answer your questions. We can kind of do that in a real-time sense. It would be great. Also, if you guys can see Mike Eno on your video, he'll be doing little samples showing bearing, showing chain, and how we do some of the things. So we're going to get right along and get started now. Boom.
I'm the Vanna
Okay.
White.
There you go, Vanna. Good job. We're going to start right at the very, very most important one, radial ball bearings. Okay, and this is how the nomenclature works. All right, we're going to have different types of radial bearings. These are the bread and butter. These are the most common. Okay, they come in inch and they come in metric. All right, they also come in standard 52, 100 through hardened steel.
Mike, pull up your next screen, I think.
I did. It's not coming through?
No, just 101 is still up.
What about now?
No.
Oh, come on, man.
Like where you at? Nomenclature?
Yeah.
I see it.
Yeah, I see it too.
My
Oh,
screen
okay.
must be frozen. Okay.
You're gumming up the works, Eno.
Eh?
Okay, but I digress. So we're going to go through this box by box, guys. It's very simple. The first box will either be blank or it'll have something in there denoting SS for stainless steel or possibly even an F. And an F would be flange, so there'd be a flange on the bearing to hold it into place in the application. The next box, you see a 62 in it. That calls out the basic type of bearing of the series. Okay, now, inch radial bearings, there is the R series and there's the 16 series. Okay, the R series such as R8, R10, or the 16 series like 1630 or 1635. Both of these come in inch dimensions, all right? And, they can either be open or they can be closed with either metal shields or rubber seals.
There's an example of a shield on that, which is what? Your right, my left. And then a rubber seal there, just so you can see.
Yeah,
Very simple.
The shields will look metallic and the seals will look plastic. Moving on to the metric side. All right, we have a bunch of different series in radials. We have a miniature 600 series. We have thin line series, the 618 and 619. Okay, those are extra thin on the width on the 618 and thin width on the 619. Okay, and then really the leaders, the big series in this is the 6000, 6200, 6300 series. Okay, and again, Those numbers denote their duty, their workload. 66,000 would be extra light, 6,200 would be light duty, 6,300 would be medium duty. They do make a 6,400 heavy duty, but that's not as common, okay? And lastly, you see a 52 and a 53 series. Those are both metric dimensions, but they have their double row. They're going to have 2 rows of ball rolling elements inside the bearing. Okay, the 5200 is light and the 5300 is medium duty. Okay, that next box is going to denote your bore size. And there's a good explanation in that little blurb below it, okay? Above 04, you multiply by 5 to get the bore size of the bearing in millimeters, okay? Anything before 4 is denoted in that box. For example, 6200 is 10 millimeter bore, 01 is 12, and so on and so forth. But as soon as you get to 6204, you times that 04 by 5 and you get 20 millimeters. If it said 6210, for example, that would be a 50 millimeter bore. All right.
The bearing I have here is an 06, so it's measuring 30 millimeters. It's a light series, but then the outside diameter is 48 millimeters by 9. Very simple to measure. It comes out exactly to 30 millimeters on the bore. There's no in-betweens. Okay?
Very good. Thank you, Mike.
Sure.
And moving on, the next box, we got seals and shields are going to be in that box, your enclosures. Okay, ZZ denotes double shields, the metal shields. A 2RS would indicate double seals, double contact seals. They're going to have a double lip seal, and it's going to be full contact. There are different types of shields. There are different types of seals, but for this case, this works perfectly fine. That's the most common that you'll see. Okay, in the next box, we're going to have internal clearance. All right, and you see there C3 because that is the most common clearance in a bearing. And that's going to be a little looser than, say, a standard clearance. If a bearing is standard clearance, there would be either empty or it'll say C0. Okay, C2 is a little tighter than standard. C4 is a little looser than C3. On the next slide, we're going to see a little cross-section of a bearing, and I might be able to explain clearance in a more visual way for understanding going for you on the next slide. The last box, that's going to be extra markings. That's going to be any type of special features or grease codes. Okay, this is showing us NR, which is for snap ring. Okay, and a snap ring is just a little retaining ring that goes in a groove carved into the outer ring of the bearing that'll hold the bearing in place. PRX is a good example of a grease code, Polyrex EM grease, or SRI2, another example of grease codes. So, you know,
this unit that I'm holding up has a white food grade lube in it, but you won't be able to see that because this is a cutaway, but that's what that last part of the nomenclature calls out lubrication, or it could call out lubrication.
Right. And then, you know, as a whole, very simply, if you had a stainless steel bearing, you would call it out as a SS 6203 ZZC3 FM222 is the food grade grease call outs. And that's how you would call out a bearing. Here's the cross section I alluded to earlier. Okay, there's a few things that I would like to point out. First are the parts of a bearing. Okay, and we'll start with that inner ring. Okay, that's the inner ring. All right, you'll see the ball roller element in between the inner ring and the outer ring. And what I want to bring to your attention is the curvature on the inside of the inner ring and the outer ring that the ball sits in and runs in. Okay, that's called a raceway. That curvature is called a raceway. And clearance, if you look at the top of that cross section, clearance, if you remember C2 or C3 or C0 from the last slide, is the difference, not the distance, the amount of space in between the ball and the raceway in a bearing. That's what they mean by clearance. So
Mike, one thing here, C3, is that the same as EMQ or electric motor quality?
It is. It is. Most electric motor quality comes through as C3. Okay? And the last part I just want to bring to your attention, you'll see, a little piece of metal that holds the balls in place in the race. That's called a cage or a retainer. That one, there are different types. That one happens to be a ribbon retainer.
This one here I'm showing is just a non-metallic one.
Yeah, that's non-metallic. That's actually made of nylon. They do come in different materials. The other thing that I wanted to point out here, and this is very important. Some bearings, sometimes they don't have the part numbers on them, or they're worn, or they're so dirty you can't read them. You might need to identify a bearing using the dimensions. Okay, when you're obtaining your bearings dimensions, you always want to use calipers. It's very tough for us to discern what type of bearing you may have if somebody says, well, I can fit my thumb in the middle, which we get a lot. People say that, and it's not possible to, you need calipers. They're the only things precise enough when you're dealing with, 16ths of an inch or millimeters. And the way you want to call out your dimensions is as follows: inner diameter, outside diameter, and then the width. Okay, so that's how you're going to call it out. And for example, if you had a 6205 bearing, and you didn't know that, but you were calling out the dimensions, the inner diameter is going to be 25 millimeters. If you remember, it's over 4, so 05 times 5 is 25 millimeters. So it would be 25 millimeters. The outside diameter is 47 millimeters. And the width is, I believe, 19 millimeters.
You're right.
And that's how you would call it out. Oh, I have a bearing. It's 25 by 47 by 19. And that will safeguard you from from having anybody make any mistakes when they're trying to identify your bearing. All right? And I think that's it for the bearing part. That's that's the basics on what you need to know for radial bearings. We're going to move on to mounted units, and this is the nomenclature graphic, and we'll go through it. A mounted unit, Mike, if you want to maybe pull up some pillow blocks or
Sure.
some 2-bolt, you know what I'm saying?
Here's a
See if we can
standard
show.
pillow block cast iron, 4-bolt. This one happens to be stainless steel, 4-bolt flange. 2-bolt cast iron style, and 4-bolt white thermal plastic for the food industry with stainless insert. Okay.
Right. There are two components to a mounted unit. Okay, there's going to be the housing, and then there's going to be the insert bearing, and there are different varieties of both. Okay, on the insert bearing, they'll come with either an eccentric locking collar or some set screws. All right, HC would denote eccentric locking collar.
There's an eccentric lock.
Yeah, off to the left a little, Mikey. You're off to the side. There you go.
All right.
UC would call out set screw locking collar. Okay, and that's what's gonna lock the bearing to the shaft. Okay, we have light duty, eccentric and light duty set screw, which is denoted by SA and SB respectively. Those are going to have curved outer rings. If the application calls for a flat outer ring, you would use a CSA or a CSB. That C would denote a cylindrical OD, which is completely flat, not rounded or beveled. Okay? Now, the housings. As Mike showed you before, he showed you a pillow block. He showed you, and that was denoted by a P. Okay, he also showed you a 2-bolt oval flange, which is denoted by FL, and he showed you a square 4-bolt flange, which is denoted by F. Okay, and what kind of happens is we take the insert and we take the nomenclature for the housing and we mush them together. So a pillow block would be called a UCP, okay? And then the next box would denote this basic series. And they range from 201 to 215. Each series has a couple of different bore sizes within it. Okay, and when I say basic series 201 to 215, I mean there's a 201, then there's a 203 series, which would have like 3/4 shafts in there. The 205 series has 1-inch shafts in that series. And this goes hand in hand with the next box. Okay, that 16 denotes the shaft size in inch dimensions. Okay, and these dimensions are called out in 1/16ths of an inch. So for example, this call out UCP 205-16, because it's in 1/16ths of an inch, is calling out a full inch bore. Okay, if it was, say, for example, 1.5-inch bore, that would be a UCP 208-24. Okay, and remember, because we're going in 1/16ths of an inch, that 24 would call out 1.5 inches. That final box, again, is going to be, any optional features of the bearing. Okay, that's showing you R3, which is a special type of seal. It's a triple lip seal. There's more drag on the bearing, but it keeps out more dirt. You might see something in there like BO for black oxide coating, or SS for stainless steel. K is where the bearing runs completely free spinning. There is no drag at all. T calls for a concentric locking collar. We call it, the Triton brand calls it a premier lock. It locks down onto the collar. It's very effective. So this is how we go as far as nomenclature on mounted units is concerned. We're going to move on next.
What do you got?
Okay, you should see a graphic of a pillow block here. All right, and what you're going to see is, of course, the housing, and then you're going to see a drawing of the insert bearing on the inside. Okay, and up top, you're going to see a Zerk fitting or an oil fitting, okay, where that allows you to refresh the grease with inside the bearing and the housing. Okay. What's important about this graphic is that it's showing you the critical dimensions on mounted units. These are the dimensions that you have to make sure are spot on to ensure that you're getting the absolute proper mounted unit for your application. Okay, so firstly, you're going to want to make sure that your inner diameter is correct. If the shaft is 1 inch, you're going to want the inner diameter to obviously be 1 inch. Secondly, that bolt hole to bolt hole dimension on the bottom should be measured with calipers directly center of the bolt hole. Okay, for example, on that bearing that Mike Eno is holding, it's a 1 inch. Correct. It's a 1 inch pillow block. Okay, that bolt hole to bolt hole dimension should be 4 1/8 inches.
4 1/8.
Okay. The third and final critical dimension is going to be base to center height. Okay, and that's going to make sure, that dimension is going to make sure that the shaft is riding properly in the unit.
That one can be a little tricky to measure though, but measuring from the base of this unit to the center of the bore, you can, you just got to kind of look at it and get a little guesstimation. But if you have a catalog in front of you, it's a little easier.
Okay. Yeah, very good. But those are the 3 critical dimensions as far as identifying a bearing if you don't have any part numbers. Now, most likely, just so you know, you'll see the series on the housing. So it might say, for example, P205. There it is on the corner of that one in particular. But it might say P205, and that's going to tell you it's a pillow block in the 205 series. And then you really would just need to know the shaft size, and it can be identified from there.
And then generally on the seal or the outer ring of the bearing are additional part numbers. Grab those 2 if you can. Okay?
Yeah. All right. Going forward, we're going to move on to chain now. Okay, and here's the nomenclature screen for the chain. All right. What we're calling out right here in this graphic is double pitch conveyor chain. And the reason why we're doing that is because it kind of fills out all the boxes for a general idea of what we're looking at. Okay. Regular roller chain, inch chain comes in 2 varieties. It's got the regular roller chain, 25 to 240 pitch. Okay. And it also comes with double pitch drive chain or double pitch conveyor. Okay. Now that first box will let you know if it's double pitch drive or double pitch conveyor with an A or a C in it. Okay, that second box is calling out the 2-inch 2080 pitch conveyor chain because of the C. All right, if it was the next box is the material or the description of the chain. It may be blank, which is just regular steel, or it may have an NP in there for nickel-plated chain, SS for stainless steel chain, or HP for hollow pitch. So that you'll see that right in there to let you know exactly the material the chain is made of. The next box is going to tell you the number of strands. Okay, that's calling out single strand. If it was double strand, it would be a 2.
Here's a sample of a double strand chain. So it's just two strands connected together through a long pin. But they make it, what do we carry, up through -4, Mike?
No, up to some sizes in 3.
Oh, okay. All right, -3. Okay.
All right, that next box lets you know what type of chain it is, whether it's riveted or collared, or if it's a heavy series. And finally, that last one again is going to be special nomenclature. Okay, that CL calls out that it's a connecting link. If it was an offset link, it would say OL in that box. Otherwise, the chain may have special variations, which would be denoted in that box. Okay, if we were to call this out, you would say C2080 NP-1R CL. Okay, that's a connecting link call out. If we were calling out the actual chain comes in 10-foot boxes, and in some cases 50-foot reels and 100-foot reels. We would end up calling out the chain length as C2080 NP-1R by 10 feet, or maybe by 50 feet or 100 feet if we are interested in getting a reel. Okay, and that's how we call out chain.
This one thing, this sample that I've got is riveted. There's a collared version, and opposite the rivet head would be an extended pin with a cotter key through it. So, but riveted is pretty standard on the smaller pitch, and you get into collared as you get up into larger chains because they're a little easier to take apart than a riveted 140 chain. Okay.
Thanks, Mike.
Sure.
Okay, now metric chain. It's really the same thing. The only thing that's different is going to be, the letters or the numbers that they're using to call it out. Otherwise, it's called out the same way as inch chain. You'll see in the first box, there's 04B, 05B. That's calling out different types of millimeter chain. Okay, so 05B-1 means single strand. SS calls out the material. In this case, happens to be stainless steel. And again, the last box is going to be either connecting link, offset link, or any special variation you may have to the chain, such as maybe attachments, maybe a D1 attachment or something like that. And that's, it's pretty simple and straightforward. You would call this out 05B-1SS by 10 feet if you were looking for 10 feet of 05B chain. Okay. Identifying chain is essentially pretty simple. It's just a measurement from the center of one pin to the next. So if you were looking at
this particular chain here,
yeah, if you were looking
this
at
is a number 50 chain, so it's 5/8, so it's 5/8 of an inch pitch.
Right, and you would just measure from pin to pin. Okay, and Mikey, if they want to get overzealous, what would they do?
Well, there are, on some metric chains, you got to be careful. You've got to get a roller diameter and a side plate thickness, because there are some heavy side plates versus standard side plates. But the metrics are just a little tricky, but you're going to basically run into inch 90% of the time. Okay. So pin to pin, roller diameter, inside width of the chain, and side plate thickness. That'll give us everything we need to know. Okay?
Thanks, Mike.
Sure.
Hey, one other thing. When in doubt, check the sprocket and see what the sprocket has any.
Absolutely.
On it.
Absolutely.
Thanks, Davey.
Yep.
My 2 cents.
And finally, we've hit sprockets, guys. And as Dave said, that goes hand in hand with the chain. Okay, a sprocket's going to be called out in accordance to the chain that it's partnered with. All right, so for example, here you see in the first box 50. Okay, that means it's using 50 chain. That's going to be the 5/8 pitch on the sprocket, and it goes hand in hand. Okay, that second box is going to call out the type of sprocket that it is. It's either going to be an A plate. Mike, if you want to pull up that idler.
Yep. So this is an A plate. It has no hubs on the side of it. This one happens to be an idler. It's got a bearing pressed into it.
Right. It's going to be either a B hub, which will not have any keyway. It won't have any set screws. And it's going to come in one bore size, a minimum plain bore size or stock bore size. Or it's going to come BS type, which is board to size, hub type sprocket. There you can see the set screw and the keyway put into the board to size sprocket. Okay. The next box just counts out the number of teeth. All right. We need to know how many teeth are going to be on a sprocket to effectively help you. And that next box calls out if those teeth are hardened or not. After a certain size, they don't need to be hardened. We harden ours up to industry standards. Okay, and finally, that last box is the bore size. Okay, it could say by 1, it could say by 1 1/4, 1 1/2, what have you.
Or 1.875 in this case.
There you go. Mike, would you be kind to show how you measure the pitch on a sprocket, please?
Sure. That's the dimension from center of tooth to center of tooth, which would match up with and I'm getting 1 1/4, so 1.25 inches. So that means it's a number 100 because it's 10/8.
There you go. Thank you, Mike.
Sure.
And then, you know what, going forwards, the simple call out is 50 BS20H by 1 inch.
And
Okay.
they're usually marked. Somebody's very proud of their sprocket. They'll put the part numbers on there. So, it'll call out 100 BS by 1 7/8 and 9, always one set screw over key. Sometimes it's one at 90. The second key could be at 90. Some people do something different with that second set screw. But obviously that set screw is to keep the piece of key stock in place under the keyway. Okay.
Mike,
Yes.
Yes.
hardened sprockets, are they all the Triton brand, all hardened?
All hardened on what we call the pinion sprocket. So the driver sprocket, which is always the small one that's turning at the greater speed, as opposed to the driven sprocket, which is the reduction one. So yeah, depending on the size, on some of them we might go up as high as 20 or 24 tooth on like a 50 BS24. But once you get up into the 30, 40, 50, 60 teeth on the big guy, no need to have it hardened anymore. Okay.
Got it.
Okay.
All right. And this brings us to our last slide. Mike, you might want to keep that sprocket in your hand because we only have the cross section, the side cross section here.
Sure.
Yeah. And that's the front view. Mike Eno's view there. Mike to the left. Okay, so it's very simple. You want to make sure you know the inner diameter of your sprocket. You also want to know your outer diameter of the hub. Okay, that's going to be two main things when you're identifying a sprocket. And then, of course, you're going to need to know the number of teeth.
And then obviously our pitch, but the hub diameter we make to the industry standard, so you shouldn't have any issues there. Okay. One thing I might mention is I've got these gloves on, and the only reason I do is I've been handling these bearings, and they're all new, and I don't want to get my, everybody's hands have a little bit of moisture on them, and it would leave little rusty fingerprints all over these bearings, which we don't. Sprockets and chain, no big deal, but that's why the gloves. I just didn't want to destroy good inventory.
And I appreciate that, Michael.
That's yours. Have we got questions now, maybe, or David?
In response to what you just said, maybe down the road we can look at kind of like a bearing handling and maintenance kind of
Sure.
something, because you touched on a good point there that probably didn't really make a whole lot of sense to people.
Here's an example, Dave. I had a spherical roller bearing here, not a ball bearing, but as you can see, it's a double row spherical bearing with a bronze retainer. You do not want to be handling this thing with your bare hands. If it's not the right bearing, you put it back, it will end up with corrosion on it just from the moisture on your hands. That's a $250 bearing I hate to see you destroy.
Yeah, the oils and the whatever moisture on your skin will eat away right away at those bearings.
Right.
Yeah, but that's something that maintenance people need to be taught as well. That just the handling of that bearing contributes to over 50% of the bearing's life.
Yeah, exactly. This one isn't oiled as heavy, but this is a cylindrical roller bearing. And again, I don't want to leave my fingerprints on this guy, so that if it gets put back on the shelf, it wasn't the right bearing. It's in good shape. It's usable. So, all right. Yeah, that's a good idea, Dave. We could do that sometime.
Yeah.
So,
I'm thankful for the opportunity that we had today. I don't see any reason why we couldn't do a bearing handling and maintenance as like a bearing 201.
Right.
You know what I'm saying? Next quarter. I thought I enjoyed this, so that's a great idea, Dave. I'm going to get to work on it actually.
Dave, we'll get with you too.
It's a
We can
great,
cover.
it's a great continuation of it, right? So,
Sure. And we can hit on other things besides the radial bearings. As you know, there's cam foulers and tapered roller bearings, all of it that's available. This is just a good start for everybody that's, looking to start somewhere on the basics of ball bearings. Okay.
Awesome. And in the world we live in, everybody should have rubber gloves now anyway. So
That's where I got them. Yeah. All
you
right.
own rubber gloves?
What's that?
Never mind.
Oh, yeah. Grocery shopping gloves.
yeah. So, but that is my presentation. I do hope that it cleared up some things for anybody out there in webinar world. I thank you for spending your time with me. It's greatly appreciated. And you know what? I hope to see you all again. If you have any questions, you can always direct them to Dave, for example, and he can get to me or anything. But I thank you all.